Well, hi there, boys and girls. Today we're going to talk about increasing and decreasing functions in the first derivative test. And we are beginning our journey on what does f prime say about f. So we're going to get some definitions out of the way. Number one, we're going to say that a function is increasing on an interval if for any two numbers x1 and x2 in that interval, and this x1 is less than x2 means we're moving left to right. So as we're moving left to right, the y-coordinates must also be getting bigger. So f of x1 must be less than f of x2. That's a way of saying that the y-coordinates are getting larger as well. And a function is going to be decreasing if the opposite is true, is as you move left to right, if the function value or the y-coordinate x1 is actually larger than the function value at x2, then we're going to be decreasing. So this is a fancy notation way of saying increasing and decreasing. Now our test for this, if your derivative is positive for all x in an open interval from a to b, then we're going to say that f is increasing on the closed interval a to b. And then if f prime is negative for all x in the open interval a to b, we're going to say that f is decreasing on the closed interval because it begins decreasing on a and stops decreasing at b. So we're going to use closed intervals here. And then if f prime is 0 for all x in a to b, then f is constant. It's not increasing or decreasing. F is constant on that interval. All right, now what does this tell us? If for some reason we have a critical number, and of course we have a differentiable function or we wouldn't be taking derivatives, then if f prime changes from minus to plus, that means from negative to positive, if f prime changes its mind from negative to positive, then this point, this critical point, and the y value at that critical point, that is going to create a relative minimum. That's going to be a relative minimum of f. If f prime changes direction from positive to negative, if it goes from increasing to decreasing, then we're going to say that that critical point C and its y-coordinate, that's going to be a relative maximum. So let's go see what that looks like and answer some questions. Find the intervals where f is increasing and decreasing, identifying all points that are relative max and min points, and justify your answers, and then we have to sketch the graph. Wow. All right, so first of all, we are going to find critical points. So I'm going to find the first derivative of f, which is going to be x squared minus 2x minus 3. And then I am going to look for critical points. So what I'm going to do is factor this. Well, that will be x minus 3 times x plus 1, and I'm going to set that equal to 0. That happens when x equals 3 and when x equals negative 1. So I'm going to show you a way of organizing your thoughts. So I'm going to draw a little number line here. I'm going to get back to my pen. All right, I'm going to put these critical points on this number line, only the critical points, negative 1 and 3. And I am going to check the sign of f prime, and that's going to tell me something about f. So I'm going to check the sign of f prime in this interval from negative infinity to negative 1. I'll try f prime, I don't know, at like negative 2. F prime at negative 2, which is in this interval, I've got f prime up here in factored form. That would be negative 5 times negative 1, which is a positive 5. That means that if f prime is positive, what does that say up there? What did we just say? If f prime is positive on an interval, then f is increasing. So there is an interval where f is increasing. Then I'm going to check another point in between our critical points. Let's try f prime at, I don't know, 0. 0 is my little email there, sorry. 0 is a critical, it's not a critical point, it's a point in between negative 1 and 3. And if I plug that in, I'm going to get a negative answer. So that means that f prime is decreasing on that interval. Sorry, f is decreasing on that interval because f prime is negative, f is decreasing. And then I'll try something past 3. Let's try a test point of like 4. That would be 1 times 5, or 5, and that is a positive number. So that means that f went back to increasing. So this is a sign chart to help me organize my answer. So here's what I'm going to say. F is increasing on the interval negative infinity all the way up to, and I'm going to include -1. You would not include a negative infinity, however. Also with 3 to infinity. And my reason is because f prime is positive on that interval. Then I'm going to say that f is decreasing on the interval from -1 to 3 because f prime is negative. And then we're going to look and see if we can find relative max or relative mins. At -1, at this critical point, f went from increasing to decreasing. F prime changed from positive to negative. That creates, and you can even see it here, the maximum. So I'm going to say that f has a relative maximum at -1 because f prime changes. We have to say f prime changes. We got to appeal to a change in the derivative. F prime changes from positive to negative. Then look back up there. There's another thing that happens. There's a relative minimum at 3. So I can say that f has a relative minimum at x equals 3. I could say at 3 or at x equals 3 because f prime changes from minus to plus, or from negative to positive. All right, let's go take a look at another example and see this again. Find the intervals where f is increasing and decreasing. Identify all points. Well, that's the same thing that we just did before. Now here, oh, was I supposed to sketch my graph? I think I was. I think I got ahead of myself. Use your results to sketch your graph. Okay, so I'm going to have to extend this page and sketch this graph. I have to come up with a graph that's increasing, then decreasing, and then increasing. And I also have to create a relative min and a max at these points. So let's get myself a little axis here. All right, get back to my pen. All right, so let's combine all of this. We're increasing all the way from negative infinity to -1. So I'm going to say -1 here. And then at -1, I have a relative maximum. And then I'm going to decrease until I get out to 3 to create a relative minimum. And then I'm going to increase after that. So I'm just going to, I don't know the y value, so I'm just going to sketch. We're increasing until we get to -1, create that relative maximum. Decreasing until we get to 3, create that relative minimum, and then increasing elsewhere. That's what that graph will look like. Because of increasing and decreasing max and mins, I can sketch the curve. All right, let's do it again. And this time I've got a different function that's going to look pretty interesting. Let's find the first derivative. So f prime is going to equal 2/3 times x squared minus 4 to the -1/3 power times 2x. Got to use the chain rule there. I'm going to clean that up and call that 4x over 3 times the square root, sorry, it would be the cubed root, put a little cubed root here, of x squared minus 4. Cube root of x squared minus 4. All right, so that's my f prime, and I'm going to find my critical points. Now here, my critical points, I have to set the top equal to 0, and I also have to set the bottom equal to 0. And the only thing that's going to make this 0 on bottom is if I get a 0 inside this cube root, and the only two values that will make that happen would be plus and minus 2. Both of those would create a 0 inside the cube root, which would make my f prime undefined, but that's still a critical point. So let's organize our thoughts here on a little number line. Okay, I'm going to put my critical points. I've got a critical point of -2, 0, and at 2. So what we're going to do is we're going to figure out what f prime's sign is, and that will tell us something about f. So if you plug in a number to the left of -2, I plugged in -3. If you plug in -3, you're going to get a positive number on the bottom but a negative number on top, which means f prime is going to be negative, which implies that f is going to be decreasing. Then I plugged in a number between negative 2 and 0, like negative 1. If you plug in negative 1, you're going to get the cube root of a negative number here, and then you're also going to have, which is going to be negative, and the top is also going to be negative. That's going to create, because negative divided by negative is positive, that's going to create a positive f prime, meaning that the function will go back to increasing. And then from 0 to 2, if you plug in a number like, 1, it will make the bottom negative but the top positive, which creates a negative f prime and a decreasing function. And then if you plug in a number bigger than 2, like 75 or something, it doesn't matter, any point in between 2 and infinity, you're going to get a positive f prime, which means an increasing function. So let's figure out what our statements are. We are going to say that f is increasing on the interval from bracket negative 2 to 0 and from 2 to infinity. And I won't put a bracket on the infinity because f prime is positive. And then I'll say f is decreasing on the interval negative infinity to 2, also 0 to 2, because f prime is negative. Then I would say that we have a relative minimum at x equals negative 2 because f prime changes sign from negative to positive. That's what happened here. It also happens, I'm going to say x equals negative 2 and x equals 2 because it also happened here. And then I'll say that we have a relative maximum at x equals 0 because f prime changes sign, changes from positive to negative there. And now let's see if we can come up with a graph of this equation. Let's see if we can come up with a graph. And I'm going to see if I can graph it down here. All right, on top of that, I'm going to come back up here and show you something. The critical points negative 2 and 2 came from an undefined derivative. They were critical points, but they have an undefined derivative. So what happens, what is one place that you can have an undefined derivative? If you have a continuous graph, one place is a sharp turn. So we're decreasing until we get here to negative 2, and I'm going to bounce and make it a sharp turn. We're going to increase and then create a relative maximum there at 0, like we said, and then decrease to negative 2 or positive 2, and then bounce with a sharp turn back up like that. Why are these sharp turns? Because they came from the f prime being equal to 0 on the bottom. So f prime was actually undefined at these points. I've got my relative maximum here at 0. I have a relative minimum at negative 2 and at positive 2, and I have the correct decreasing, increasing, decreasing, increasing. All right, well, I see that there's another example here, but I think that's probably enough, and I don't want to have to do another one for you there. But you guys will practice this, and I will see you guys tomorrow.